standard form, you need to just have 8.47. And in that case, it read times 10 to the 8, because you made the decimal point. You've done 6 already, you did 0. 1, 2, so you have to add an 8 there at a time. Or mass times gravity times distance over time, or mass times acceleration times distance over Ali, over what? What's the last one? What do I need to put there?
T.
Look at that pattern.
Oh yeah, what? T.
Yeah, so work done, force times distance, mass times gravity. Gravity times
Gravity times distance.
Rosie, can we use the equation v squared equals u squared plus 2as? Or
V
denominator
squared
equals u squared plus 2as.
U squared is AC voltage and V is DC. A resistor has a value of
Why don't they make the colours like telephone colours?
2.
Easy.
Right. The second band is pink,
7.
so it's 7.
Yeah.
Heads. What's that one?
We've got 2 brown.
I'll get it. Heads. The value is 27.
Isn't that
Yeah.
binary?
Yeah, similar thing. I think it's similar to it.
27K, what does the K stand for?
Kilos, 1,000. And that's because the pink one at the end, number 3, gives you the times 1,000. So if you read it, red 2, pink 7, that funny brown one times 1,000.
Adding together.
And
So the first 2 are just number place values.
Put it together.
David Shop and
Not adding this one.
Yeah.
what's the next
The
one?
first 2 are the number place values. So 2, 7, and the third one's the multiplier.
And what's the division?
It's like a code, isn't it?
Yeah, it's like a code. And this last one tells you the accuracy.
And you divide that one, yeah?
Plus or minus 1%.
How
So
well
this
made
one's
it.
yellow, so it's saying it's 27,000 ohms, plus or minus 5%.
Average.
Rosie, the division sign and so what's it dividing there? That's value, yeah?
Yeah, so you're thinking, this, there is, so this is the first, if it's in the first position, it's 1. If it's in the second position, it's 1. And if it's the colour band in the third position, it's times 10.
The bigger the cross-sectional area, the less the resistance. The smaller the cross-sectional area, the higher the resistance. Temperature also will affect the resistance of the cable. The hotter the cable, the higher the resistance. The exception to this rule is carbon, being a semiconductor, which we know from previous presentations works in the opposite way around. In other words, the hotter the carbon becomes, the better a conductor it becomes, therefore if the resistance is lowered. As well as looking at length, temperature and area affecting the conductor's resistance, we also looked at its resistivity. And we said silver has a lower resistivity than copper, therefore is a better conductor. And aluminium has a higher resistivity than that of copper and silver, therefore is not as good a conductor as the other 2. However, all 3 are widely used for different applications within the electrical industry, with copper being the most common material used in conductors. We went on to work out the resistance of a conductor by using the formula resistance equals the resistivity multiplied by the length divided by the area. In other words, resistance equals rho L over A. Again, these video presentations are to put us in the position where we get the amount of knowledge required to go into the exam where a calculator wouldn't be used. Remembering the formula resistance is rho L over A is a good way of getting marks within this section. I'd like to think that we can apply that formula and rearrange it to find 3 others, whether it be length, resistivity or area. But again, the presentation is about that surface knowledge required for our principles exam. We're going to on to look at two statements that again appear in our exam. Resistance is proportional to length, and resistance is inversely proportional to cross-sectional area. So, if I have a cable with a resistance of 10 ohms, and I double its length and remeasure its resistance, its new resistance will be 20 ohms. If I take the same cable with a resistance of 10 ohms and halve its length and remeasure its resistance, its new resistance is 5 ohms. They are proportional. Double it, double the size of resistance, half the size of resistance.